You want to get started with platform engineering, but all you hear are buzzwords? Everybody speaks about internal developer platforms, but there are no best practices. Nobody really tells you what repeatable patterns for platform designs are. Hey, I'm Kaspar from Humanitec. In this video, we're going to deep dive into how to architect an enterprise-grade internal developer platform. An internal developer platform, abbreviated IDP, is a set of tools and technologies that a platform engineering team binds into a golden path to enable developer self-service along the entire lifecycle of an application. By providing developers with self-service capabilities while driving standardization, IDPs significantly boost productivity through a reduction in waiting time, distraction, or manual work for operation teams. A recent benchmarking study we did on platform engineering has shown that IDPs are the single biggest driver to help an organization innovate faster and slashes time to market by an average of 30%. When we are architecting IDPs, we usually follow a number of design principles. First, golden paths over cages, or in other words, make simple things simple and complex things possible. What that means is that developers should be given the freedom to choose the level of abstraction and never be boxed in. The internal developer platform should provide a set of golden paths that developers can follow, but they should not be forced to follow them. The second principle is standardization by design. Shifting the focus on self-service means that platform engineers define ways to vend resources and configuration. This means that every resource is built securely, compliant, and well architected. Dynamic over static configuration management. This essentially means that rather than syncing unstructured config files, developers write a recipe that expresses the workload and its dependent resources in an environment-agnostic, general way. A rules engine, a platform orchestrator, reads that recipe and pulls baseline configurations and infrastructure templates that are specified by the platform team beforehand. This recipe, which could for instance say, my workload needs a database of type Postgres, and those default configurations set by the platform team, allow the orchestrator to create app and infrastructure configurations dynamically with every single deployment. This reduces configuration complexity by up to 95% and drives developer self-service, standardization, and unified interfaces. The next principle is to leave interface choice to the developer and never break their workflow. Developers should be given the freedom to use the interfaces they are most comfortable with. An internal developer platform should never break their workflow or force them to use a specific interface. Because of this, we're opting for code-based workflows by default, while leaving the options to use a UI, CLI, or API. I encourage you to keep code as the single source of truth. This ensures that everyone is working from the same version of the code, and it reduces the risk of errors. By default, we assume a brownfield situation. This means that when building our internal developer platform, we assume that there are existing systems and processes rather than assuming a greenfield situation. Now that we have our principles, let's actually get into architecting. There is no one-size-fits-all for IDPs. The platform at a large financial institution in New York will differ wildly from the platform for a startup in New Delhi. But after analyzing hundreds of setups, we identified architectural design patterns that most modern platforms have in common. To make it easier to convey the architectural design of those platforms, we have dissected them into 5 separate planes. Each plane takes on a specific job within the wider platform. Let's go through those planes one by one. First, we have the developer control plane, which clusters the primary interfaces developers can choose to use when interacting with their platform. Such an interface could be a workload specification for a fully code-based interaction, a developer portal or service catalog for an UI-based view, or an API and CLI. The integration and delivery plane contains the flow of a request from the interface all the way down to the configured resource. It includes CI pipelines, the Platform Orchestrator, maybe a dedicated CD system, and sometimes a dedicated infrastructure control plane. We then have the resource plane, which encompasses all cloud and on-prem resources. This includes compute, databases, file storage, or DNS. The security plane includes the policy layers and secrets management, and lastly, the observability plane, logging and APM functionality. So, how do you get from the abstract understanding of the individual planes to your actual internal developer platform? Faster than you think. Here's a quick step-by-step guide how I like to approach platforming. Design the individual planes first. Start with the resource plane because it dictates other design decisions on other planes and layers. I then usually propose to proceed as follows. Focus on the integration and delivery plane next. The pipeline design, the configurations of the orchestrator, then proceed with the security plane, the monitoring and logging plane, and do the developer control plane last. Because this heavily depends on the design choices of the other planes and should definitely come last and after thorough testing of developers. Once the individual planes are designed, wire them together with the other planes. Once you have that, continue with setting baseline configurations for app and infrastructure configurations, then set deployment and environment progression automations, then design and implement role-based access control, and once all of this is done, onboard your first application. If you are using our reference architectures, you should be able to have a first version of your platform up and running in roughly a day, and then you can iterate from there. If you are a developer developing your application on your brand new internal developer platform, you should now be able to self-serve everything you need to build, deploy, and operate your application and resources. It's important to point out that this goes way beyond the creation phase of a service. Well-crafted platforms treat every single deployment like day zero and create application and infrastructure configurations dynamically with every single Git push. To achieve this, the developer formulates a general recipe. That recipe states what resource their workload depends on in general. An example would be, my workload depends on a database of type Postgres. Every time this workload gets deployed, the Platform Orchestrator interprets this recipe, essentially acting as a rules engine. It looks up the configurations the platform team has configured, and based on those configurations, it dynamically creates the final app and infrastructure configs and deploys them. This ensures consistency and standardization across the entire lifecycle of your application. Building an internal developer platform is like building a product, and you should definitely treat it as a product. That means starting small, applying best practices, interviewing your users, and constantly iterating. Thank you for watching our video on how to architect an IDP. If you want to get started on your platforming journey, go check out our library of reference architectures. You can simply download the one closest to your setup and get building right away.